You're listening to The Local Maximum, episode 219.
Time to expand your perspective. Welcome to The Local Maximum. Now, here's your host, Max Sklar.
Welcome, everyone. Welcome. You have reached another Local Maximum. The dark side of artificial intelligence, I think, gets the most of the attention in the media. But there are countless ways that AI has improved our lives. Some of it is 100% silent and unknown to those who are not in the know, and even unknown to people like me who, don't know the way that AI and machine learning are applied in every single industry. Nobody can know that. And so we're going to dive into one notable example today. But before, I just wanted to ask you guys, how did you like returning to our roots of machine learning and AI the other day? I know that it might be jarring for some people out there who might be more into the current events or the issues stuff and some vice versa. But actually, I'm always surprised by how non-phased some people are. Some people out there, I think a lot of you out there just have the same interests as me. We talk about things that are interesting to me on the Local Maximum, and I hope that it's interesting to you too. And in many cases, it seems like it is. So we're going to continue for a few episodes along these lines. I'll give you the plan at the end. And it was also great to start Local Maximum Labs. Hopefully I'll have an episode, or not an episode, I'll have a website up about Local Maximum Labs, maybe a blog post about the bias-corrected machine learning paper that I just put out. So I hope I'll get to communicate more to you on that as well. So, all right. And if you want to join the conversation, got to remember to talk about this. If you want to join the conversation, head to our locals at maximum.locals.com. I appreciate everyone on there. I always check to see what the messages are and what conversations we're having on there. And also, you could just email the show at localmaxradio@gmail.com. So today, we're going to cover two great fields that are often covered, two great topics that we cover on the Local Maximum. One is AI and the other is entrepreneurship. AI specifically in places that you wouldn't expect. We've done it before. I think the notable episode on that is with Lisa Palmer in episode 148. And also on entrepreneurship, one of my favorite episodes in the past is I've interviewed entrepreneurs and founders in all different circumstances, but my favorite is still the first one with my good friend Dennis Crowley in episode 7, who founded Foursquare. And today we're going to combine those two. We're going to learn how AI and a form of machine learning, specifically, we're going to talk a little bit about simulations in machine learning, how this is making construction projects more efficient around the world. And I really do mean around the world, as you'll see in just a moment, because my next guest is the founder of Alice Technologies and is an adjunct instructor at Stanford University's PhD program in construction engineering. René Morkos, you've reached the Local Maximum. Welcome to the show.
Great to be here. Thanks for inviting me, Max.
All right, so let's just start. By setting the stage and tell me a little bit about your company, Alice Technology. Maybe tell us a little bit about how you started it first, and what market did you see? What type of technology did you build to solve it? What did your first MVP product look like? What does it look like today? That sort of thing.
Lots of questions there, I guess. Let me kind of run you through how the company was formed, or what was the kind of the aha moment, right?
Yeah.
And I wish there was two. There's one, but there's two. And so the first aha moment is I am building landing strips for F-16s in Afghanistan, of all places. And it's a concrete slab, relatively simple project, and I'm trying to figure out how to sequence it. And I got about 30 guys or 33 guys, and I'm thinking, well, if I put 4 over here and they do rebar there, and the production rate changes, and I move them over here, and I can't seem to figure out the optimal solution. I got a solution, it works, right? But and I keep thinking okay, it would be kind of cool to have a computer kind of figure all this out for me, right?
Yeah.
And I think to myself, okay, so the computer that figures this out for me, I went to find it. I went to UC, did my master's there, went to Stanford, did my PhD, kept looking for the software tool that would do that. And it didn't, I didn't really, I didn't find it, and I ended up building it. And I think the other way that I kind of, ended up doing this was I was building or helping build, I should say, the cruise ship terminal in Amsterdam. And the cruise ship terminal in Amsterdam was at the time 6 weeks late. And every day was 50,000 euros. And these guys were pretty stressed out because they had kind of blown through the profit on the job. They're sort of, yelling at each other. And I got up, looked out the window, and I noticed that there was, 100,000 square foot of empty space and 6 people standing in it. And I realized that construction sites are empty. Right? Look at any construction project anywhere in the world, and there's lots of empty space.
Yeah,
right?
there's one out here. Absolutely.
Yeah. And I never when you look at it, there's this kind of work happening, in a pocket somewhere, right? But it's not like there's a lot of work happening in all places. And I measured that on average, 3% of construction site space is used for construction, right? And so 3%, so like, holy cow, like if you can increase that, right? You should be able to reduce project duration. And so I got started in, being in Silicon Valley, being at Stanford at the time, I was doing my PhD. Started to realize that there's lots of different ways you can increase space usage. Like you could sort of schedule A, B, and C at the same time, or maybe you could do A, D, F, or A, D, E, or whatever the, allocation of tasks was. And so, started to fidget around with algorithms. And that's kind of one of the questions that you asked, like, what did Alice used to look like? What does it look like now? Well, Alice, when we started, was literally a screen that would show you these little squares that would pop up. And so the view was like a top-down view. Imagine you were sort of in a helicopter looking down at a construction site.
So these squares, was this a map? Each square?
Yeah, the map would be where the work was occurring.
Okay.
So, somebody building the column in the, upper corner, there would be a little blob, a square that would appear as I'm building that column.
Right.
And
right.
so, yeah, these, and at one point we realized, like, oh, we should change the colors of the squares so that you can kind of differentiate between different tasks, right? And so, they would have a little timer on the right side, and it will imagine like a bunch of squares. And the great thing about Silicon Valley is that we raised, I think, $500,000 based off of that, right? A bunch of squares dancing on a screen, but the graphics sucked, right? But what it was actually doing was pretty nifty. It was actually telling you how to build a construction project. It was literally telling you, here's what you need to do to build a project, right? And so from there, we started to build, product around it, right? We had a technology, we needed a product. And so, today it's really polished, very nice looking sort of thing that you can, set up and schedule and resequence. And yeah, it's a beautiful piece of technology.
Okay. I want to get back into the product and the tech, but I want to go back first and ask you about a couple things that I heard. So the interesting projects, you were in Afghanistan, you were in, where was the cruise ship terminal? Was that in Amsterdam you said? Yeah. So give me a sense of what was the timeline of those versus when you started Alice, and like, how did you end up in Afghanistan? Because you mentioned of all places, and it's like, well, hold on, I don't want to just let that go.
I mean, it's the top tourist destination for anything. Yeah, I guess I never liked school, which is kind of interesting because I'm now an adjunct professor. I would cut class in my bachelor's degree and go volunteer in construction projects, right? And so what I would do is I would basically go to knock on these doors and say, hey, do you guys need a construction engineer, right? And they'd say, no, buzz off. You look like you're 18. And I was like, I am. What if I were 8? And they'd say, okay, well, sure. And so, I did the Lebanese University at the time. I was studying in Beirut, American University of Beirut. I did Lebanese University. I did underwater pipeline, a couple of sort of minor jobs. And then I wanted to go to Afghanistan. I thought it would be a great experience personally and professionally. And so I went to Kabul. I worked as a private contractor. for a company. Our official slogan was Hara Construction Afghanistan. Take it easy, we will build it again. Yeah. So yeah, I did that. Then ended up, finished that, worked in Dubai for a while, worked in the Bentley Motors showroom, worked on a whole bunch of projects around the world, ended up doing a PhD, did my master's at USC, did a PhD. What I wanted to do was I wanted to do what they call an industrial PhD. So it's 6 month on, 6 month off, sort of back and forth. And so
that sounds like a good idea.
Yeah. And I'm kind of, surprised that, that this isn't a more like well-known or used way to do a PhD, because, it was really, really cool. I'd go to the field, try out these, prototypes I had. I'd go back to the lab, improve them, tinker with them, then go back to the field, try them again. So it was very applied research in a lot of ways.
Cool. Yeah. So, right. So the timeline. So the timeline before we move on. When did you start Alice, and when were you working on those previous projects?
Yeah. So I started 99, started my bachelor's degree, graduated in 2004, was in Afghanistan in 2005.
2005. Okay.
Yeah. 2005, pretty much all of 2005. End of 2004, all of 2005, almost, bled into 2006. And then started my PhD at Stanford in 2009. Yeah, and then did this 6 month on, 6 month off for the first 4.5 years. And so I was going to Amsterdam and back, and that's kind of where I picked up the Amsterdam experience.
Yeah, I'm just trying to get a sense because a lot of people want to start new things. I want to start new things, and there's always this sense of, I'll build something, and 6 months later the idea will come to fruition. And I feel like oftentimes it's many, many years of having a certain interest and a certain passion and being sparked from different directions that kind of go into it. It sounds like that's what happened in your case.
Yeah, for sure. Right. I didn't actually set out to found a company. We won the Basic competition at Stanford, the entrepreneur competition on campus. And we were voted the best product coming out of Stanford University that year. So the thing that I like, the average time, here's a few statistics that are interesting, right? The average time to create a company is 7 years.
Wow.
Right. Something like 1% of the companies that apply for funding get funded at the seed stage or at all, right? So something like 99% don't get funded, right? And then from that 1% that do get funded, the numbers drops 10% of them or 20% of them make it to the Series A, and then 10% of them make it to, and so the chances of succeeding are pretty slim, right? The 7 years, like you were saying, do you need to have a whole bunch of interest in the company? That is one way it happens, right? I've also seen the other way where somebody picks something I had a friend that said, hey, I'm going to go trucks, right? Trucks tires, right, or really suck, right? They blow up and they cause all these issues. And I'm going to
see them on the road over there.
See them on the exactly right. And I'm going to go focus on that. But
yeah,
then, you're saying, well, I don't have all this disparate all these experiences have kind of coagulated into this one idea. I focused on this idea, but the end result's still the same because, if you do it that way, you still have to go do a whole bunch of research on trucking companies and truck tires and what the pricing model is. And, so whatever you're going to do, you're going to end up in some situation where you spend 7 years iterating on something, tinkering with it, going back to the drawing board, tweaking it, and so on and so forth. And I think that 7 year mark is really interesting because if you look at consultants or professors or lawyers, right? Generally, the 7 year mark is when you kind of get to be partner. If you're working at a consulting company like McKinsey, 7 years is when you make partner, right? Plus minus could be 9, right? Law firms, very similar. Law firms is similar. Professors, right? You get tenure after 7 years, right? And so it seems that 7 year mark is, I think, roughly what humans are capable of delaying, the end goal for, right? In some kind of a meaningful mass way. And so what I'm trying to explain is that I think that the reason it's 7 is because people start to quit after 7.
Right.
So the ideas that needed more than the 7 years, people don't do. And the idea that needed less than 7 years, a lot of those have been already done. So I think that's why that 7-year number kind of, is where it is.
It's almost like a market for time preference, time delay preference or something.
Yeah, exactly.
Yeah. All right. So let's get back to your initial product. Like what was going on in the background? So I'm picturing this map, and maybe you guys can also send me some little screenshots if you want. I could put it on the show notes page. But I'm picturing this map with little things of what's going on. But what's it doing under the hood? How is it recommending to you, which tasks is it recommending to you which tasks to do in what order? Is it telling you who to hire, what to put where? Is that kind of thing that I'm picturing? And how is it doing that? Like brute force? You start with brute force, or is it doing something? Did that not work? Did you have to start with something a little more complicated than that?
Yeah. So the Alice is a generative construction simulator, right? It's a bit of a mouthful, but here's what that means. So if you're unfamiliar with generative technology, don't worry, you'll be an expert in about 30 seconds. And so the way I explain generative construction is through an example of generative design, right? So let's assume that you want to draw, I don't know, a cup, right? So you kind of draw sort of 2 circles in a plane, right? Some kind of cylindrical shape. If you want a bigger cup, you redraw it. A smaller, you got to redraw the cup every time there's a change. Somebody came along and said, hey, what if I have like a parametric tool? It has parameters, height and diameter. So I can change the parameters and the tool redraws the object. So you're like, oh, well, that's kind of cool.
Right.
So changing parameters and having these changes ripple through your system is parametric. Generative simply means that I don't want to change the parameters one by one. You, the computer, try all the parametric values from 1 to 10,000 and give me the design with the greatest, power output, the building with the greatest rentable area, or whatever it is, whatever optimization function you're looking to optimize. And so for us, Alice is a system that takes a construction project, you put it in our system, and it can generate 6 million different ways of building it for you. It will build your project with 1 crane, 2 cranes, overtime, no overtime, right? And so it is what you were saying. It will tell you the optimal sequence in which to construct, the optimal number of cranes, the optimal number of crews, right? It will tell you all of this stuff. So that's basically how the system works.
Right. So, but like if you have too many parameters, you have too many combinations, you can't really brute force every single combination, can you?
That is correct. There's no, so let's start with why is it simulation? Right, it's a generative construction simulator, right?
Yeah,
it's simple. There is no mathematical answer to the riddle that we're trying to solve, right? So you can't look at a construction project and say, okay, it needs 6,000 tasks, and these tasks need these resources, and these resources are being used in this, then I have these many resources available, and this is the sequence. These are the potential sequences. There is no mathematically tractable way to solve this. And so if there's not a mathematically tractable way to solve it, then simulation is the way to go, right? And so you are correct. There are too many sequences out there for you to be able to do all of them, right? There could be, half a trillion, half a billion, there's a very large number.
Yeah, there's some crazy exponential, 10
There's one of the things that's interesting about our field, which is that here's a question. All right. So let's assume that you're building and you've got, three foundations, foundation A, foundation B, foundation C. And so you build A, then B, then C, and you kind of simulate the project, and the project takes 100 days to complete. Right.
Right.
If you build CBA, right, instead of ABC, so you switch the sequence, you build CBA, is your duration going to be like 10,000? No.
Sorry. Wait, what was the question? So it's you're trying it 2 different ways, right? And then
if you build A, then B, then C,
right,
and you get a duration of 100.
Okay.
You build C, then B, then A. Is your duration going to be 10,000?
No, it's not going to be an order of magnitude different.
Exactly. That's exactly the point. So the thing is that when you resequence the work, you'll generally in construction see, 20% maybe change, right? So what I'm trying to point out is that if you're dealing with optimization folks, which, we have a whole bunch of them in the company, very smart folks, they tend to spend a lot of time wondering about optimal solutions. Right? Like, is this optimal? And there's this mathematical ways in which you can start figuring out whether a solution is optimal and so on and so forth, right? The actual answer in construction is that we don't need to guarantee optimality, right? If we generate 10,000, 100,000 simulations, we start to get a pretty good idea of what the range of available, durations or costs or whatever it is to us. Right. To give you an example, like, if you run 1,000 simulations, you'll get durations between 100 and 130. Right.
Right.
And if you run an additional, 10,000 simulations, usually you don't see that much of an improvement. Maybe you'll get like a 99 to 131, right, or something, right? Like you'll start to see very little improvements beyond that, 10,000 simulation number.
So what's kind of the strategy to search the space then? Are each of these simulations just generated randomly, or are they done, some kind of hill climbing? What's the
It's not a question that we openly share, but
okay.
To answer your I can give you sort of some ideas of how we're approaching it, right? One of the things that's interesting is that we are intimately familiar with the problem. And so the good thing about, doing construction scheduling and only construction scheduling and construction scheduling over and over again, every day of every week, every year, like we do construction scheduling, is that you start to understand some specific properties of the construction schedule. And so you will start to understand that the order in which you resolve constraints, helps and sort of those kind of things. The other thing that's sort of interesting is, is it random? Like to some extent, like what isn't, right? So yes, right. Like your original solution has some randomness in it, right?
Oh, sure. Yeah.
You're using your knowledge, your heuristics knowledge, that you understand some of the heuristics around the problem. And so you're sort of narrowing down the state space. If that makes sense. Right.
Right.
The state space. The other thing that's kind of interesting about, here's an interesting one as well, which is in terms of randomness. So one of the things that was really sort of interesting for us is that when you run Alice, right, the computer scientists always want to explore more options. The more options you explore, the bigger the chances you have of finding a more optimal solution, a better solution.
Right. So you want a bigger space and you run into cursed dimensionality.
Exactly. Right.
Yeah.
What's kind of interesting is that for us, when we run Alice, right, let's say that you run Alice and you run it 1,000 times. And it looks at 1,000 different ways of building your project, and it says, here's the fastest of those 1,000. But let's assume that somebody on the other side of the planet runs that same simulation, just simply clicks rerun on it. If it gives you different solutions, it really messes with the user's head in the sense that the user's like, what the bleep, right? This thing,
right.
I hit simulate twice and it gave me completely different results, right? And so what's interesting is that the randomness of our solutions, there's a give and take in the sense of if you rerun it, we want you to have the same 1,000 runs that you had originally. So there's a pseudo random generator. And so that this push and pull between more variability, i.e. greater optionality, so greater potential to optimize, versus less variability. So I have the solutions that I'm familiar with, alternatively solutions that are better and match what I have in my head more, right? That's an interesting kind of almost philosophical dynamic at the company, right? Which is, more freedom, right, gives more power, right? But also you can have more junk, right? And less freedom means less power, but more closely aligned with what I expect to see. And that's an interesting, interesting kind of, edge that we kind of, skate around. And it's we've learned a lot as we've applied these things.
Yeah. I guess what I'm thinking now is this podcast is called The Local Maximum. So I feel like it's obligatory to ask, do you make sure that the results are at least a local maximum? Like, do you fiddle with it? Like you find nearby solutions and
Absolutely.
make sure at the top?
So you can, with this solution space, you will end up at a local maximum. And so what the software does is it kind of rejiggers the seed, so to speak, to knock you out of that and then sort of start looking at other local maximum.
Right. And then you find the best local maximum you can. It might not be the global maximum, but like you said before, it's going to be pretty good.
It's going to be pretty good, exactly.
And probably the global maximum is not much better.
No, but it's like the way I've explained it is like, is there a solution out there that is like 1 day shorter than than what's available from these 10,000 runs? You can get hit by a meteorite, but the chances are pretty darn slim, right?
Right.
Is there a solution out there that's going to be like 100 days or 50? No, there's not, right?
How do you deal with the fact that a lot of this is not really even deterministic? Like, a lot of tasks could be like, this might not take 5 days. This could take 3 days or 7 days, and there's some probability distribution. Does that make the product a lot more complicated?
Yeah. That's a really, really like critical key question to anybody working in optimization or AI or ML or anything. The first question that we had to answer as a company is are we building a stochastic or a deterministic system, right? And so for users, that are unfamiliar with the terms, deterministic means that you assume that reality is going to, match exactly, how you said it. So, it takes 5 days to build a column. So every column in this building is going to take 5 days, right? And you assume that the crew shows up and does what it's supposed to. It's deterministic. It's predetermined how this is going to play out. There's a different way to do it, which is stochastic, which is I'm going to roll some dice, right? So the column is 5 days. It could be plus minus. It could be 6. It could be 4, right? Alice is a fundamentally deterministic system. So you might think, anybody kind of learned in the arts, so to speak, would say, what the heck, a deterministic system, that's not useful. Reality isn't deterministic, right? There's always variability, right? People are tired that day, so they work slower, or they want to get home early, so they work faster, right? There's always variability in your system. So
right.
The thing that I think a lot of people miss, and this is my sort of, opinion, is that a deterministic system doesn't necessarily mean that you're not able to deal with variability, right? There's two kind of ways, two points that are important here. One is that in a deterministic versus stochastic system, first of all, you rarely, at least I've not seen it, I would imagine that it does exist somewhere, but the probability distributions are not known. So when you say, hey, I want, for a stochastic system, you don't say the column takes 5 days. You say the column takes anywhere between 3 and 7 days, right?
Right.
But, is it like, here's some questions, right? Is it between 3 and 7, or is it between 2 and 8? Or is it between 4 and 8 or 5 and 8? And if it's between 3 and 8, is it a normal distribution, or is it most of the time it's closer to 3, right?
Yeah.
Only rarely is
probably log normal. Yeah.
Right. Exactly. Right. So what I'm trying to explain is that nobody has these probability distributions, right? You can assume a normal distribution, fair enough, right? You can say, it's going to be, closer to, 3 or 8. So A, no one has those probability distributions. B, even if you did, here's the issue. So what the software is going to do is it's going to run that simulation for you. And it's going to say in certain cases, the column is going to be 3. In certain cases, the column is going to be 8. Right? But the problem is that I wasn't there when that dice was rolled. So when you run it, here's where the deterministic systems allows you to account for these probabilistic, factors. When I run a deterministic system, I can say, you know what? We were going to get the building permit in June. And so when we're going to work on earthwork, we were going to work quickly because it's not raining. But now it's January, right? And it's going to be raining, and that's going to mess up our earthwork. So I can go into my system and I can tweak the production rate for earthwork. So what I'm saying is that in a stochastic system, it becomes very difficult to see where the buffer in the system is or isn't, right? Especially if it was done randomly. So what's kind of confusing about it is that the system doesn't think to itself, columns for this project are some weird column that was imported from China that nobody's how to build. So I'm going to apply a, longer than average duration to all the columns in the system, right? Or vice versa, right? And so with a deterministic system, you can apply that, stochasticity into it is a point. And the last point I'll make is that what's really cool about a deterministic system is it's very quick to update any changes that are happening in real time, right? So the probability, let's assume that the production rate is lower or higher. You can just update your system and hit resimulate, if I'm making sense.
Yeah. I think this whole stochastic versus deterministic discussion is really interesting. I think it gives us like real insight into how some of these statistical models work in the real world. And it sounds like it's really an important design decision based on what your application is. So it sounds like in yours, deterministic is the way to go. And if you want to look at different things that could happen, different scenarios, you simply input those and you get a bunch of different scenarios.
Yeah.
Is that what I'm getting right? Yeah. So, that's very fascinating. It sounds like if you try to do stochastic as well, everything just becomes a lot more complicated as well on the back end.
Here's the deal, right? You have a stochastic system. I've used them, right? The stochastic system has 1,000 tasks, right? And each of those tasks has some duration. It can be done in 3 days or 8 days. Minimum 3, maximum 8. Minimum 10, maximum 20. Minimum, maximum. So you might
each of those might have 100 different scenarios, and then you have all of a sudden.
But then, so the system runs it. You say, roll the dice, pick a randomly duration between the two numbers I gave you, and run it. And then so the system comes back and says you have an 80%. I ran 500 simulations, and for 300 of them, the duration was 100 days or less. So you go to your boss and you say, I have a 60% chance of finishing this project in 100 days or less.
Yeah.
What does that mean? Like, what do I do with that? I need to deliver this job to the client in 100 days. So you want me to go to the client and say, well, we have a 60% chance of delivering on time. It's like, no, you're going to deliver this on time. That's what we pay you to do, right?
Right.
So that's the challenge with these stochastic systems. And there are certain, instances where you have the probabilities, right? There are certain probability distributions that have been calculated, right? Great. Then we can use it. For a field like construction, no, we don't have that data.
Yeah. So, okay, I want to shift gears a little bit because you've been optimizing construction projects for a while now. What do you find is usually the bottleneck for these construction projects? Like, what kind of advice does your software give these project managers or give the people running it that seems to work really well? Like, do people say like, oh, I never would have thought to do it this way?
What's interesting about the software is that most of, probably 70% of the cases, so whether that's most of, like, probably 70% of the cases we see the software figures something out that the human didn't. And here's an example, right? So we were working, one of the earliest jobs, this is kind of one of the first times the system, quote, outsmarted me. And so in construction, you tend, let's say you're building a multi-story parking lot, right? And so in construction, what you try to do is you try to put your steel on Thursday so you can pour the concrete on Friday and it dries over the weekend, right? So concrete dries,
makes sense.
Right? Nobody's working on the weekend, so you want it to be drying on the weekend. And so in construction, my dad was in construction. He kind of raised to put the steel on Thursday, pour it on Friday, dry it out, cure it over the weekend, right? What's interesting is the software, when we ran the simulations, did something that I've never seen before or thought about. And what it did was it did that expected pattern on the first floor. But on the second floor, it cured or dried the concrete during the week. Which you're like, wait, why would it dry the concrete during the week? That doesn't like that, because no one's your labor force that's available isn't working, right? They're waiting for the concrete to dry.
Right.
And the third floor was weekend. The fourth floor was week. The fifth floor weekend. And then originally I was thinking like, is it possible they're just like really, it went through 3 million sequences, but it screwed it up, right? Or what's going on?
You're like thinking, is there a bug? Is there
exactly? But then when you looked at it, what we realized was that if you had forced the software to do, dry the concrete on the weekend, on the next floor, it would have to wait. It was like it was ready to pour the concrete on Tuesday. And if you had to wait, you would have pushed it out till Friday, if that makes sense. So like for it to do weekend, it would have to wait. And so what it realized was actually the optimal cycle. So in our field, you're always thinking in terms of cycles. Very strangely, wasn't one floor. Because for us, we're always thinking in terms of, one floor is one cycle. So I got to get the cycle down for one floor, right? And what the software figured out is that the optimal cycle was 2 floors, right? So that's one example of it sort of figuring out something that we didn't know. And it happens a lot.
Yeah, that's actually a really fascinating example. I guess it kind of makes sense. Like if you're ready to pour on Tuesday, then maybe go on Tuesday. But you also kind of want to have it in the week, and then having that, it makes sense that alternate works, I guess. But you wouldn't really think of it. You wouldn't really, you wouldn't be sure if someone suggested it. You'd be like, "Are you sure?" I don't know. Okay, yeah. So that's really interesting. I think we're about out of time, but maybe you could tell us a little bit about where people go to learn more, and maybe any last thoughts, some concluding ideas to summarize what we went through today.
Yeah, definitely check out our website, alicetechnologies.com, plural, Alice Technologies. Shoot me an email, Rene@alicetechnologies.com. We're always keen to sort of work on projects, commercial infrastructure jobs, 100 million and up. That's our sweet spot. If you've got any sort of complex project that's running into trouble, we'll run it. And I think like closing sort of thoughts, what's happening in the construction industry right now is incredibly exciting. What's happening in construction is what happened in manufacturing in the, call it 70s, 80s. Right, construction is becoming digitized. It's becoming sort of a high-tech, high-end field. 2017 was sort of the turning point for us, and so I'm really excited to see what's going to happen in the next 10 to 15 years as more and more companies like ours start to saturate the market. Very great, Rene, and also this will be available on our show notes page, localmaxradio.com/219. Rene, thank you so much for coming on the show. Max, great to be here. Thanks a lot. Have a good day. All right. That was quite a lot of fun. Next week, it'll be either me or just me and Aaron maybe, and we'll talk about some more AI news. That'll be more current events driven. And the week after, I have an episode for you on AI and emotion. So that'll be really interesting. This is a big AI month here on the Local Maximum. Have a great week, everyone. That's the show. To support the Local Maximum, sign up for exclusive content and our online community at maximum.locals.com. The Local Maximum is available wherever podcasts are found. If you want to keep up, remember to subscribe on your podcast app. Also, check out the website with show notes and additional materials at localmaxradio.com. If you want to contact me, the host, send an email to localmaxradio@gmail.com. Have a great week.
Feel the power.